Introduction to Private Connectivity. Welcome to our comprehensive comparison of private connectivity solutions across the three major cloud providers. Today we'll explore how Azure Private Link, AWS VPC Interface Endpoints, and GCP Private Access enable secure, private communication to cloud services. Private connectivity is crucial for enterprise workloads that need to access cloud services without traversing the public internet. This reduces security risks, improves performance, and helps meet compliance requirements. Each cloud provider has developed their own approach to this challenge, with different architectures, pricing models, and capabilities. Understanding these differences is essential for making informed architectural decisions. What is private connectivity? Private connectivity allows your resources to communicate with cloud services using private IP addresses, keeping traffic within the cloud provider's network backbone rather than routing through the public internet. Think of it like having a private highway between your office and a destination, instead of taking public roads. The traffic is isolated, more secure, and often faster because it doesn't compete with public internet traffic. This is particularly important for sensitive workloads, compliance requirements, and scenarios where you need predictable network performance. All three major cloud providers offer solutions for this, but they work differently under the hood. Azure Private Link Overview. Azure Private Link is Microsoft's solution for private connectivity. It creates a private endpoint in your virtual network that represents the Azure service you want to connect to. What's elegant about Private Link is that it uses a network interface with a private IP address from your VNet's address space. This means the service appears as if it's directly in your network, making it intuitive to understand and configure. Private Link works with many Azure services like storage, SQL database, Key Vault, and even third-party services through Private Link service. The traffic never leaves Microsoft's network backbone, ensuring high security and performance. AWS VPC Interface Endpoints. AWS VPC Interface Endpoints, powered by AWS Private Link, provide private connectivity to AWS services as well as third-party services. They create an elastic network interface with private IP addresses within your subnet. The key advantage is that you don't need to modify your applications. They can continue using the same AWS service endpoints, but traffic is automatically routed through the private interface. This makes migration to private connectivity seamless. AWS offers both interface endpoints for API-based services and gateway endpoints for S3, and DynamoDB interface endpoints support hundreds of AWS services, and are typically the more flexible option for most use cases. Moving on to GCP Private Google Access. Google Cloud's approach here is slightly different, using Private Google Access and Private Service Connect. Private Google Access allows your virtual machines that only have private IP addresses to reach Google APIs and services. Private Service Connect is Google's newer, more advanced solution. It's similar to Azure Private Link and AWS Interface Endpoints. This service creates private endpoints that consume private IP addresses within your VPC. What's unique about GCP is that they also offer private Google Access for on-premises networks, enabling hybrid connectivity through Cloud Interconnect or Cloud VPN. This often makes it more straightforward than what other providers offer. Architecture comparison. Let's look at how these three solutions differ architecturally. Each provider has taken a different approach to solving the same fundamental problem. Azure Private Link creates a dedicated network interface in your subnet, making the service appear local to your VNet. AWS Interface Endpoints also use ENS but can be shared across multiple subnets in an AZ. GCP's Private Service Connect creates forwarding rules and uses internal load balancers to route traffic to Google services. This provides more flexibility in how traffic is routed but can be more complex to set up. The diagram shows the high-level architecture differences and how traffic flows in each solution. Supported services comparison. Service coverage varies significantly between providers. AWS has the most comprehensive coverage, with interface endpoints supporting over 100 AWS services out of the box. Azure Private Link supports most core Azure services and has been expanding rapidly. What's interesting is their strong support for third-party services through Private Link service, allowing SaaS providers to offer private connectivity. GCP's coverage is growing but historically lagged behind AWS and Azure. However, their Private Service Connect is catching up quickly, and they have unique capabilities for hybrid scenarios. The table shows the current state of service support, but this changes frequently as all providers are actively expanding coverage. Pricing is where these solutions differ significantly. The total cost can vary greatly depending on your usage patterns. Azure charges per private endpoint per hour, currently around $0.01 per hour, plus data processing charges. This makes it predictable for budgeting, but it can add up with many endpoints. AWS charges per VPC endpoint per AZ per hour, plus data processing fees. The multi-AZ nature means costs can be higher for high availability setups. GCP's Private Service Connect pricing is per forwarding rule per hour, with additional charges for data processing. They also offer some free tiers for certain services. Let me show you some real-world cost scenarios to illustrate the differences. Setting up Azure Private Link. Let's walk through creating an Azure Private Link endpoint. The process is straightforward through the portal, but I'll show you the Azure CLI commands that give you more control. First, you create the private endpoint resource, specifying which service you want to connect to. Azure automatically creates the network interface and assigns a private IP from your subnet. The key consideration is DNS resolution. You need to configure private DNS zones so that the service FQDN resolves to the private IP instead of the public IP. This is crucial for applications to work correctly. Azure provides automatic DNS integration, but understanding how it works helps troubleshoot connectivity issues. Setting up AWS VPC Interface Endpoints. AWS VPC Interface Endpoints are created through the VPC console or CLI. The process involves selecting the service, specifying which subnets to place the endpoint in, and configuring security groups. One important decision is whether to enable private DNS names. When enabled, the standard AWS Service Endpoint DNS names resolve to the private IP addresses of your interface endpoint. Security groups control access to the endpoint, allowing you to restrict which resources can use the private connectivity. This provides fine-grained control over access to AWS services. The CLI commands shown demonstrate creating an endpoint for S3, including the policy that restricts access to specific buckets. Setting up GCP Private Service Connect. Google Cloud's Private Service Connect setup involves creating forwarding rules that route traffic to Google APIs through private endpoints. The process is more complex than Azure or AWS but offers greater flexibility. First, you create a Private Service Connect endpoint that consumes an IP address from your VPC subnet. Then you configure DNS to resolve Google API endpoints to this private IP. The gcloud commands shown create a Private Service Connect endpoint for cloud storage. Notice how we specify the target service attachment and the subnet where the endpoint should be created. One advantage of GCP's approach is that you can use the same Private Service Connect endpoint for multiple Google services, reducing the number of private IPs consumed. DNS Configuration Deep Dive. DNS configuration is critical for all three solutions, but works differently in each. Getting this wrong is the most common cause of connectivity issues, so let's break down exactly how each provider handles DNS resolution. Azure uses private DNS zones that automatically integrate with your virtual network. When you create a private endpoint, Azure can automatically create the DNS records, making it the most user-friendly approach. AWS provides private DNS integration that overrides the public DNS resolution for AWS service endpoints. This means your applications don't need code changes, they continue using the same endpoint URLs. GCP requires more manual DNS configuration, but this gives you more control over how resolution works. You can use cloud DNS private zones or configure your own DNS servers. Security considerations. Security is a primary driver for adopting private connectivity. However, each solution has different security models and considerations you need to understand. All three solutions provide network-level isolation by keeping traffic off the public internet. However, they differ in how you control access and how you implement additional security measures. Azure Private Link integrates with network security groups and can be combined with Azure Firewall for additional filtering. The private endpoint appears as a regular network interface, so standard network security practices apply. AWS Interface Endpoints use security groups for access control and support endpoint policies for fine-grained IAM-based restrictions. You can also use VPC flow logs to monitor traffic. GCP Private Service Connect integrates with Cloud Armor and firewall rules. The forwarding rule approach provides flexibility in implementing security policies. Performance characteristics. Performance is another key benefit of private connectivity. The actual performance characteristics vary between providers and depend on your specific use case. All three solutions generally provide lower latency than public internet routing because traffic stays within the cloud provider's backbone network. However, the performance gains depend on your geographic location and the specific service you're accessing. Azure Private Link typically shows 10 to 30% latency reduction compared to public endpoints, with more consistent performance. Performance is especially noticeable for storage operations and database connections. AWS Interface Endpoints provide similar performance benefits. An added advantage is that you can place endpoints in multiple availability zones for optimal routing and high availability. GCP's performance benefits are often the most significant because their global network infrastructure is particularly strong. Private Google access can show dramatic improvements for API-heavy workloads. High availability and disaster recovery. High availability is crucial for production workloads, and each private connectivity solution handles HA differently. Understanding these differences helps you design resilient architectures. Azure Private Link endpoints are regional resources that automatically provide redundancy within the region. If you need cross-region connectivity, you'll need separate private endpoints in each region. AWS Interface Endpoints can be deployed across multiple availability zones within a region, providing built-in redundancy. The multi-AZ deployment is recommended for production workloads, though it increases costs. GCP Private Service Connect forwarding rules are regional, but Google's global load balancing can provide cross-region failover capabilities. This is particularly useful for globally distributed applications. For disaster recovery, all three solutions support cross-region connectivity, but you need to plan your private connectivity strategy as part of your overall DR architecture. Monitoring and troubleshooting. When things go wrong with private connectivity, you need good monitoring and troubleshooting tools. Each cloud provider offers different capabilities for visibility into your private connections. Azure provides Azure Monitor integration with Private Link, allowing you to track metrics like connection count, data transfer, and DNS resolution. Azure Network Watcher helps with connectivity troubleshooting. AWS offers VPC flow logs, CloudWatch metrics, and AWS X-Ray for distributed tracing. The VPC Reachability Analyzer can help diagnose connectivity issues between your resources and interface endpoints. GCP provides cloud monitoring for Private Service Connect metrics, VPC flow logs for traffic analysis, and Network Intelligence Center for network topology visualization and troubleshooting. The key is setting up monitoring before you need it, because troubleshooting private connectivity issues can be challenging without proper visibility. Third-party service integration. One of the most compelling features of modern private connectivity solutions is the ability to connect privately to third-party SaaS services, not just first-party cloud services. Azure Private Link service allows any service provider to offer private connectivity to their customers. Companies like Snowflake, MongoDB Atlas, and Databricks offer Azure Private Link integration. AWS Private Link has the most mature ecosystem with hundreds of third-party services available through the AWS Marketplace. This includes everything from databases to analytics platforms to security services. GCP Private Service Connect is newer but growing rapidly. Google has partnerships with major SaaS providers, and the technical implementation is often simpler than other providers. When evaluating private connectivity solutions, consider not just the first-party services but also the third-party ecosystem that's important for your architecture. Real-world use cases. Let's look at some common real-world scenarios where private connectivity provides significant value, and how each cloud provider's solution addresses these use cases. Financial services companies often need private connectivity for compliance reasons. They can't have sensitive data traversing the public internet, and they need predictable network performance for trading applications. Healthcare organizations need HIPAA compliance and secure access to cloud services. Private connectivity helps meet regulatory requirements while enabling cloud adoption. Large enterprises with hybrid cloud architectures use private connectivity to securely connect on-premises systems with cloud services, creating seamless hybrid workflows. Each use case has different requirements for performance, security, and cost, which influence the choice of private connectivity solution. Choosing between these private connectivity solutions depends on multiple factors. Let me walk you through a decision framework that considers the most important criteria. First, consider your primary cloud provider. If you're primarily on one cloud, their native solution is usually the best choice. Multi-cloud scenarios require more careful evaluation. Second, evaluate service coverage. AWS has the broadest coverage, but check specifically for the services you need. Azure and GCP are catching up quickly in most areas. Third, consider cost implications. The pricing models are similar, but AWS can be more expensive for multi-AZ deployments, while Azure and GCP offer more predictable pricing. Finally, factor in your team's expertise and operational preferences. Some solutions are easier to implement and maintain than others. Summary and recommendations. We've covered a lot of ground comparing Azure Private Link, AWS VPC Interface Endpoints, and GCP Private Service Connect. Let me summarize the key takeaways and provide some final recommendations. All three solutions solve the same fundamental problem but with different approaches. Azure focuses on simplicity and automatic integration. AWS emphasizes comprehensive service coverage and enterprise features, and GCP provides flexibility and strong global performance. For most organizations, I recommend starting with your primary cloud provider's solution. The integration benefits and reduced complexity usually outweigh the differences in features or pricing. However, if you're building a multi-cloud strategy or have specific requirements around third-party services, AWS Private Link currently offers the most comprehensive ecosystem. Thank you for your attention, and I'm happy to take any questions.